Hello everyone, Namaste. Hope you are all doing well. In this video, I'll tell you how you can count the number of figures in a given picture. So here in this particular video, I will be discussing how you can count the number of triangles in a given figure. So I'll be discussing 4 different types of problems related to counting of triangles in a given figure. Now for this triangle, it's easy for us to count the total number of triangles in the given picture. It's because only one vertical line is there which is dividing this triangle further. So what we can do? Directly by looking, we can count it very easily. So this line divides the triangle into 2 different triangles. So this is the first triangle, this is second one. So what about the third one? When the first and second triangle is joined, means the whole outer border, so that gives us a triangle. So the number of triangles here is 3. I can write number of triangles is equal to 3. Now what if these lines which we have drawn vertically is increased? Let us consider another example. Here you go. Now you can see a given triangle has been divided further by so many vertical lines. Now it will be difficult for us to count the number of triangles as easy as in the previous case. So we might miss 1 or 2 triangles when we combine this, right? So I can number it individually. This is 1, this is 2, this is 3, 4, 5, 6, 7. Then we have combination of 1 and 2, combination of 2 and 3, 3 and 4, 5 and 6, 6 and 7, 1, 2, 3, 2, 3, 4. So like this we have to count. So in case if we miss one of these triangles, we will lose our marks. And most of the competitive exams, we have negative marks as well. So what we can do is, simply we can use a trick here. That is, by using the formula n into n plus 1 divided by 2. So this formula is used when these triangles are divided further by vertical lines from the top to the base of the triangle. What is the value of n here? Okay, so just now I have written the numbers 1 to 7. So what is that? It is by the direct eyes, when we look into the figures, we can count these triangles very easily. So those lines which divides the whole triangle into subparts. So there are 7 parts that we can see. That is the value of n. So here n is 7 now. So 7 into 7 plus 1 divided by 2. That is 7 into 8 divided by 2, 56 divided by 2, which is equal to 28. So in this given picture, we have 28 triangles. So 28 triangles are present, which can be calculated by using this simple formula. Now, again, some of you might ask, this is very difficult. We cannot remember formula. So then what we can do? These numbers what we have written, simply you add those numbers. So you add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. So this comes out to be 28. So these are the 2 ways by which you can count the number of triangles in a given figure like this. So here from baseline it has to be divided. Okay. So either you have to add the individual parts, or you can use the formula n into n plus 1 by 2. So this is the simplest method by which you can count the number of triangles. Now let's proceed further. Look here, look at this picture. Whether this is same as the previous one which we have solved? Half a part, is it? So the whole triangle is divided into 3 parts by using the vertical lines. Along with these vertical lines, now we have horizontal lines. So how we can find the number of triangles in this case? Let me tell. Okay. So baseline, previous how we have done, the same way we will write it. So here we have one part, second part and third part. So the triangle has been divided by the vertical line as I told in the previous case. Along with this, now we have horizontal line which is dividing the triangle into 4 parts. So let me label that. So here this is the first part, this is the second part, third part and fourth part. So vertical lines dividing the triangle into 3 parts, and horizontal lines divide the triangle into 4 parts. So with respect to base of the triangle, so we can count the number of triangles that is present, like how we have done previously. That is 1 plus 2 plus 3, which comes out to be 6. What to do with these horizontal line? So we have counted there are 4 parts. You just multiply it. So it is 6 into 4. That comes out to be 24. So the number of triangles in this particular picture is 24. Let us consider another similar example. So here you can see the triangle. Just try to solve it. Okay. So vertical lines, it is dividing the triangle into 1, 2, 3, 4, 5 parts. Horizontal line, that's 5 parts. Vertical lines, now I have 1, 2, 3, 4 and 5 parts. So we have to add the number of parts that is made by the vertical lines. So that is 1 plus 2 plus 3 plus 4 plus 5. Or you can use the formula n into n plus 1 divided by 2. So this is 15. Then what we need to do? We need to multiply the other. So this is 15 into 5, which comes out to be 75. So in this given figure, we have 75 triangles. So this is how you can count the number of triangles in the given figure. Now let us consider another way by which this type of questions can be asked. Now see here, in between the vertical lines, there are horizontal lines. So how we can count that? So here in the first part, we have 2 triangles that is made. So I can add it. 1 plus 2, that is equal to 3. Similarly here, we have 1 plus 2. Because 2 parts are there, I have added it. It is 3. In this case, it is 1 plus 2 plus 3, that is equal to 6. So now here I have 1, 2, 3, 4, 5 and 6 parts. So we have to add all those. So I'll use the formula 6 into 6 plus 1 by 2. So 6 into 7 by 2, 42 by 2, that's equal to 21. And again at the base bottom I have 6 parts. So it is again 21. So now we have to add all these numbers to get the total number of triangles. So we have to add 3 plus 3, 6. 6 plus 6 is 12. So this is 12 plus 21 plus 21, 4, 54. So the total number of triangles we have in this particular figure is 54. Now we will move on to consider the second type of questions which can be asked with respect to counting of triangles. Now this is the type 2 questions, where like in the previous case we have horizontal line, but the other lines are not drawn from the top to bottom, but instead these are slant lines. So here we will make use of the formula. Firstly, we will consider the number of parts that a triangle has been divided by the horizontal line. So here we have first part, second, third and fourth. So horizontal lines have divided the triangle into 4 parts, and we will use the formula n into n plus 2 into 2n plus 1 divided by 8. So we will be making use of this formula for triangles of the given type as in the figure. So now the value of n is 4 here. So we need to substitute the value of n as, and now let us solve it. So this is 4 into 4 plus 2 into 2n, it is 2 into 4 plus 1 divided by 8. So we have 4 into 4 plus 2 is 6. 2 into 4 is 8 plus 1, that is 9 divided by 8. We'll just simplify this here. 4 ones are 4 twos are 2 ones are 2 threes are 9 into 3, 27. So in this figure we have 27 triangles. So this is how you can just simply solve the problems related to counting of triangles in the given figure by just using the formula n into n plus 2 into 2n plus 1 divided by 8. So let me consider another example. Now this is the second example. So this is 1, 2 and 3. So 3 triangles when it is divided horizontally, making use of the formula n into n plus 2 into 2n plus 1 divided by 8, which is equal to 3 into 5 into 3 2 is 6 plus 1 7 divided by 8. 3 into 5, 15 into 7 divided by 8, which is equal to 105 divided by 8, and we need to simplify. 8 ones are 8 threes are 24.1. So 13.1 we are going to get. So here I can write the number of triangles. It cannot be in decimal form, right? So number of triangles is equal to 13. So in this given figure, we have 13 triangles. Now considering the next type 3 problems. So what we have here is, we have triangles embedded inside another triangles. Means one triangle is present inside another triangle. In this case, we are making use of the formula 4n plus 1. 4n plus 1 is the formula that we are making use of, where n here is the number of embedded triangles. Number of embedded means how many triangles are present inside the given triangle. We are going to count it, and then we are considering it as n, and we will be using the formula 4n plus 1. So here you can see one triangle is given. Inside that we have another triangle that is embedded. So here the value of n is 1. So I can substitute into the formula. 4 into n is 4 into 1 plus 1. It is 4 plus 1, which is equal to 5. So in this given figure, in total we have 5 triangles. For this figure, you can easily count it without formula as well. So you might think this is very simple. I can count and write 1, 2, 3, 4 and the outer one. So total it is 5. Right, for this case you can count, but when the number of triangles embedded are more, how we are going to count? So let me consider another example. In that case, this formula will help you for sure. Now consider this figure. Can you count the number of triangles as easily manually like how we have done in the previous case? Difficult, isn't it? So we have to use the formula 4n plus 1. So again here we will make use of the formula 4n plus 1. So what is the value of n here? So we have one triangle, second triangle and third triangle. 3 triangles are embedded inside the outer triangle here. Here the value of n is 3. So now applying the formula 4 into 3 plus 1. It's 12 plus 1, 13. So we have 13 triangles in all together inside the given figure. So this is how you can just simply solve using the formula 4n plus 1 when we have triangles embedded inside another triangle. Let's move on further to study about the type 4 questions. Type 4 questions are where you will have a square or a rectangle that will be divided further, where you are going to count the number of triangles. So let me tell you the formula where how you can count the number of triangles here is, by first look how many triangles you can observe here. It is 1, 2, 3, 4. So the formula, first let us write the number of triangles. So this is by the first look that how many triangles we see. So it is 4. Then we have to count the number of diagonals. How much diagonals are there? So you know a square or rectangle is having 2 diagonals. So this is one diagonal here and this is another diagonal. Okay. So we have 2 diagonals. So for counting total number of triangles in the given figure, so total number of triangles, we have to multiply these two. So it is 4 into 2, that is equal to 8. So we have 8 triangles in the given figure. So let me consider few more examples in the similar way. Now look here. how many triangles do you see by your first observation? So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 triangles are there. So I'll write 8 and counting number of diagonals. So we have only 2 diagonals. This is one diagonal. This is the other diagonal. So for a square or rectangle, we have only 2 diagonals. So it is 8 into 2, 16. So the total number of triangles we have in the given figure is 16. Let me consider one more example. It's very important. So here, so this is similar to that of the first example which I have considered. Okay, where by first look we can see 4 triangles, right? 1, 2, 3, 4. Again here I can write 5, 6, 7, 8, 9, 10, 11, 12. So I have the first square or rectangle where I have 4 triangles and 2 diagonals. So total I have 8 triangles. So here 4 into 2, again 8 triangles. 4 into 2 is equal to 8 triangles. But are all these triangles we have? So few more triangles are formed where the one rectangle is joining the other rectangle. Let me show it to you. See, other than these triangles which we have mentioned, here you can see this is a rectangle. That is one. The other one is here. This is second one. Similarly here by 7, 6, 9 and 12 we have another triangle. Also here we have another triangle. So other than these mentioned, we have the other 4 triangles as well. So we have to add all these to get the total number of triangles. So we have 8 plus 8 plus 8. Along with that, the triangle which is obtained by the combination of triangles 3, 2, 8, 7. So that is one triangle. Then we have 7, 6, 9, 12. The other triangle. Then 2 more on the upper side we have 1, 2, 8, 5 plus 5, 6, 9, 10. So how many triangles we have altogether? It's 8 into 3, 24, 25, 26, 27, 28. So altogether we have 28 triangles in the given figure. I hope you have understood how you can solve any questions related to counting of triangles in the given figure. If you have any queries, please do not hesitate to post your queries in the comment section below this video. If you find this video helpful, please do like the video and share the video among your friends and family. Thank you for watching. Stay connected, keep learning, take care, bye-bye.